now that we can serve static HTML files, it would be great if we could also serve CSS and JavaScript files. Let's create a new style.css file in our public directory, and in it we'll add a simple rule. Let's say OH1s will have a color of red. And now we have to go to the index.html file, and in the head part we have to add a new link to a CSS file, and it automatically fills it with style.css. If we go to the command line now and we run our server, if we open a new browser window and we navigate to the address, we actually won't get the H1 in red, because if we open the DevTools and we refresh the page, we see that the browser did try to request the style.css file, but of course we returned 404 because /style.css is not a path that we have mapped in our handler. One way to handle static files at runtime would be to add extra logic to the default case here. Instead of immediately returning a 404 when we don't have a mapping for the path, we can actually capture the path, and in the body we can call read file directly and match on the result. So if read file returns some, this means that the file that was requested exists. If it returns none, we can still return a 404 because this file does not exist. So if we call self read file and we pass the path, now we have to match on a sum that will have the contents of the file, or a none. In this case, we will just want to return a 404. And if the file does exist, we want to return a new response that will be an OK response with the contents of this file. So we can say status code OK, and we just have to put sum with the contents, and we need a comma at the end. So now if we come back here and we recompile our code, when we refresh this, yes, we see that our H1 is red now because we successfully made the request to /style.css and the CSS file was returned. So this works, but just because it works doesn't mean it's correct. Some of you might be screaming at the screen right now because we have introduced a terrible security vulnerability to our server. With this implementation, we have introduced a directory traversal vulnerability to our server. Directory traversal is a web security vulnerability that allows an attacker to read arbitrary files from the system where the server is running. Before we patch this issue, let's have some fun with it. So the problem that we have is that we don't validate in any way the user input, because this path here is anything that the user can send us, and we just pass it to the file system API without any validation. We are hoping that the client is trying to read a file that is in the public directory. So we get the public path and we append the path that the client provides to it. But what would happen if the client prepends a double dot before the path? This would take them one directory up, and suddenly they can read all the files that are in the root of our project. To see that in action, we can come back here. Unfortunately, the browser would not let us use double dots in the URL bar, but to demonstrate this exploit, we can just open another terminal and we can use the netcat to send requests to our server. So now, if we just create a normal HTTP request, so let's first create one that will just work normally, /1.1, and it has to end with 2 new lines. And we want to pipe this string to the netcat, and we want to go to 127.0.0.1 at port 8080. Let's make this a bit smaller so it fits on one line. So now we see that we did send a new request and we got back the style.css file that we requested. That's great, but what will happen if we want to be malicious and we want to go one directory up and then we want to read the cargo.toml file? Oops, that is really, really bad. Right now, the client can pretty much read any file from our file system. To make this even more scary, let's try to read something else. So if we keep going up in the directory tree until we reach the root, so in my case, I know that this is 5 levels up. And now I can just go to the procfs and read the meminfo of my file system. Ooh, this starts to get really scary. So you can imagine that with this, we can also go and read all the passwords or private SSH keys or source code even. Any information that the attacker might want is readily available for them to read. So we had our fun with the vulnerability. Now let's think about a way to patch it, because it is horrible. One thing that we can do is in the read file, after we generate the path, we can just check for double dots. If there are any double dots inside of the path, we can just throw this request away and not serve anything because it's trying to do something bad. But we can be even more clever than that, and we can get this path that we have generated and try and convert it to its absolute canonical version. What that means is that we want to resolve all the double dots from the path. So let me first give you a little demonstration about what we're trying to do. In Unix, there is a command called realpath, and when we pass a path to the realpath command, it will resolve all the misdirections in the path and it will return back the canonical version. So now if we pass our up/proc/meminfo, it will give back just the root proc/meminfo. So we can do something like this from Rust, and we can check to make sure that the real path that we get back always begins with the path to the public directory. Because if it doesn't begin with the path to the public directory, that means that we've gone up the directory tree and someone is trying to hack our server. To do this from Rust, there is a very simple function in the fs module. It is called canonicalize, and we just pass it a path. So we can pass the generated path to this function, and we see that it returns a result. So we have to actually match on this result. If the result is okay, it will contain the canonical version of the path, and we'll implement this case in a bit. Otherwise, if it's an error, this means that the path was not valid. So if it's an error, we just return a none immediately. If the path does exist though, we have to check if the path starts with the public path. And to do that, there is the convenient starts with method on the string. And here we can just pass a reference to self public path. And if the path does begin with the public path, we can safely now read the file to a string. So we can read the path and we can call OK on that. Otherwise, we want to first print line that someone is trying to mess with our server. So we can print that a directory traversal attack was attempted. And we can also print the file path that the attacker tried to use. And after that, we return a none because we don't want to read this file. And now our code is safe. Let's go through it again so it's clear exactly what we're doing. We are getting the file path that we provide. In the case with the static files, this file path is provided by the client. So this is the thing that might be malicious. We are concatenating it with the public path here. And then we get the canonical version, which would remove all the double dots from the path, and it will give us the absolute canonical representation of this path. We check if this path exists, and if it does, we check that it begins with the public path. Because if it does not begin with the public path, we've gone up the directory tree and we're trying to read, or more likely the attacker is trying to read some files that they're not supposed to have access to. When this happens, we print line a message telling us that someone is trying to do something fishy, and we're returning a none. So now, if we come back to the console, if we recompile our code, and if we try to execute the same attack that we did before, yes, now we get back a 404, and we log that a directory traversal attack was attempted with this path here. But if we open a real browser and we try to make a legitimate request, we see that we still get our style.css and our heading is red.